This video is on the objective, calculate a confidence interval for the mean, population standard deviation unknown, right? So sigma is unknown, with the calculator. And this is with data sets. This is the second video, number 2 here, for a question related to this objective on your Newton-Alta homework. And these kinds of questions, you're going to be given a set of data, right? Instead of the statistics. You're not given the sample mean, you're not given the sample standard deviation. You're just given the sample itself, the actual list of data. So you're going to enter a data list and then have the calculator create a whatever percent confidence interval estimate for the population mean using that sample. All right, now since I've already done a video on this, this one's going to be a little faster. So again, if you want to see how they're doing it, right, click on more instruction. Right, just watch me do it. All right, so here are 15 people, sample size 15. 15 people were asked to measure their pulse rates after completing a 3-kilometer run. The sample data are given below. So these are all 15 of these people's pulse rates after a run, and are assumed to be normally distributed. That's important for if you're going to be using a t-distribution. Remember, t-distribution, normal, pretty close. They're both symmetrical and bell-shaped. It's just that the t-distribution, right, depends on your sample size. You have so many degrees of freedom. And it says use a calculator, right, or one of our TIs, 8384, to construct a 98% confidence interval for the mean of the population. Right, and round your answer to 2 decimal places and enter the low value and high value in order in your confidence interval there. All right, so based on this sample of 15 runners, we're going to make a guess as to what the mean pulse rate after a run is for all runners, not just these 15. All right, so pulling the calculator up, I'm just going to enter this list of data. Right, you hit Stat, go to Edit, hit Edit, Enter, and then you can go down List 1, List 2, List 3, whichever list. I'll just do down List 1, enter these rates, 104, just enter all 15 values of the sample, 104, 102, enter, and I'm going to just skip ahead and come back when this is finished. Okay, so I'm back, and I've entered all 15 of those values in list 1 here in my calculator. And then I get out of this, go second, quit, and we're going to have the calculator create a, they said 98% confidence interval estimate for the population mean, the mean pulse rate of all runners after a 3-kilometer run. So remember how to do that. I go Stat, hit the Stat button, go over to Tests, and I scroll down to number 8, right? Don't confuse these, right? Try not to confuse these. There's Z interval. That was for estimating a mean, creating a confidence interval when sigma was known. We want T interval, number 8. That's for estimating a population mean with a confidence interval when sigma is unknown, like we have here. So I go to T interval. And then, do I have data? Do I have stats? I was given a list of data. So I'm going to go down data here, and then what was that list of data? Well, it's already L1, so I'm going to leave it as L1, right? That was list 1 with all my 15 data values, all the 15 pulse rates. If you entered it down a different list, just enter a different list number. The frequency, again, there was no frequency list here. Every single one of these values is counted 1 time, so I'll just leave the frequencies as 1. And my confidence level is already 0.98. This is from I entered this earlier, so it stayed this way. But you got to enter your confidence level as a decimal, right? So if it's 98%, you got to enter 0.98, not 98, right? If it's 95%, you got to enter 0.95. All right, so enter all that stuff is entered, calculate, and then it gives you the stats, right? The mean for these 15 pulse rates, the sample mean was 105. Standard deviation is 8.5. There are 15 of them. But the top stuff's the most important thing, the confidence interval. So remember that would be this lower value is my 105 minus the margin of error, right, whatever that is, 99.216. And then the upper value is the 105, the x bar plus the margin of error, so 110.78. And we're asked to round to 2 decimal places, so 99.22, 110.78. And what we're saying here is that we're 98, based on this sample, we're 98% confident that the average pulse rate for all runners, not just these 15, is somewhere between 99.2 heartbeats per minute and beats per minute and 110.7, 110.8 beats per minute. Okay, but let me just enter these values now. Low end and high end rounded to 2 decimal places. So the low end 99.22, the high end 110.78. And submit. And again, read through the answer explanations, whether you got it right, whether you got it wrong, especially if you got it wrong, right, to see where you went wrong and try to fix it the next time you see a problem like that. All right, and that's it. Very quick and easy. Just entering, the thing that takes the longest for these problems is entering that list of data. And you got to double check it. Make sure you're entering all the values correctly, because if you mess up on one of them, it's going to throw everything off and you'll get it wrong. So make sure you're entering your data correctly before you go to that t-interval function. All right, so hopefully this video helps you when you work on this kind of problem on your own, and thank you very much for watching.